Hey there, welcome back to the channel. So today we'll be working on writing unit tests. We have made changes to the my traverse function, like the traverse previous function and my malloc function. So we have to do some unit tests, like test if our code is working. I guess there might be some kind of errors, like some errors, uh, but I guess it should. Okay, so split block pointer, line 248. Okay, so 248. Split block pointer. Okay. Yeah, okay, it should be next. Oh, what? Okay. This should be next. Yeah, yep. And redefinition of my mark. Yeah, yeah. Okay. Yep. So, and if we do this, and driver test C, which will test every traceman, and it should give us an error, yeah, ran out of memory. So why is that happening? Because we are allocating the memory, but we are not freeing it because our free function isn't doing anything because we haven't worked on it. So let's write uh, our unit test for uh, what was it? Like my malloc function. Yeah. So we'll write it over here. So void pointer void function test my malloc. So this was fine. So the thing is that our my function, when we do when we use the executable M driver, my is working. It is able to allocate the memory. But what happens is that every time it asks for memory, there is nothing in our free list, right? So we have to construct an artificial free list for the testing purposes. So that's what we will do. So let's do it. So let's say I ask block one. So this is block one and we call mem SVRK. Let's make it separate function, right? So void block one, block two, block three. Yeah, this is fine. And then we'll do we'll sorry, construct free block. Yeah. And then should I try this? This looks weird, but I guess it's better. So construct free block. What it will do is that it will take a size. So size t size. So that's what it will do is equal to, let's say, um, construct block, let's say 1000 bytes. Wait, what's happening? Yeah, find one, replace with two, replace with three, boom, 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 boom. Let's remove this. Yeah. Okay, so then we have to do a lot of different things, but that's fine. Okay, so and this must be aligned size, right? Yeah, we will align it when it comes to size t aligned size is equal to align size, and then we are we will call MemSVRK. So void pointer, let's call it simply block. So mem sbrk find size, and then we get the blocks value, and now we have to make it so like then we okay, yeah. So we should call for like the total block space, right? Yeah, size t total block total space. Let's call it total space. Yeah, it should be align size plus, or should I just make it like yeah? So size t size plus pointer size plus pointer size plus align size plus size. Yeah, this is fine. And then we ask for total space. And then once we get the like value of the block, now we have to make it so like the changes to the size t values. So the block header. So void pointer block header is equal to uh, block itself. So that's fine. Let's cast it into, since we have to change its value, we will cast it into void pointer to pointer. Yeah, and then void pointer block footer is equal to cast it into void pointer to pointer. We have to do some char pointer block, and then we'll move it by size t size. Let's copy this. So we will move it by, sorry, no, yeah, size t size, pointer size, and line size. Yank and paste. So yeah, block we move it by size t size, and then pointer size, and align size. Yeah, this is fine. And then yeah, okay, this is fine. And then we change the value of block header to bind size, and also the footer value to align size. Perfect. So I guess this is it, and we should now return also. Yeah, let's do it. So if block is equal to void pointer minus one, which is invalid. Wait, we write void pointer minus one same, right? Same way, yeah, void pointer minus one, yeah, perfect. So void pointer minus one, then we'll also return, hmm, let's return the same thing, void pointer minus one. Then why do this, right? Yeah, wait, then I can't do further operations. Okay, so if block is equal to void pointer minus one, then we'll return again void pointer minus one. Okay, and then a return block. So inside this test function, we are going to get the addresses for each of these, and we have to write another function. So like we have to make some changes to uh, the previous and next pointer values, right? So that's what we will do. So like let's write another function. So it's a simple void function. Yeah. So change ref next. Yeah, let's keep it that. So it will take now void pointer. Hmm. It will take a address of the block. It will take a pointer to a block. Sorry. So yeah, am I audible? Yeah, I guess. Okay, this is fine. So yeah, let's get into it. So change previous next. Change previous next values should be better word. So it will so here we get the value of the block. Not just the block, but we'll also get what we have to change the you can say what values to change. Change previous and then void pointer change next. We should keep change next first because like in our like design of the free block we have next first and then it's previous. So yeah. So well, let's go. So void pointer. Let's get the size of the block first. So size t pointer. Let's directly get the size t value. So block size is equal to what do we say like what is it? Not block. Hey, also we shouldn't be returning this. Like construct free block. This is fine, but we should be returning like block void pointer block char pointer block plus size t size. But I guess this is fine. Yeah, we are just constructing, not a big deal. Yeah, I guess it's not a big deal. Nah, just let's keep it formal. So pointer size plus pointer size. Yeah, okay, this is cool. So we get the pointer here. We are at next currently. Why did we move forward here? Okay, okay, okay. So we are over here. So block size is at nah. Let's keep the previous one. So yeah. So size t block size is equal to um, so our block is pointing to the right, the first, like the start of the block, right? And we did change the values of it. So I guess that is it. So size t pointer, uh, block value, and then we'll dereference it. Or can I just like simply do this? Is this valid? What is e no men? Sorry. Let's use malloc instead. So like block is equal to malloc, let's say 100 bytes. Sorry. So we got something over here. So now we will change the value of it. So like, so I'll cast it into, let's say, size t pointer. So this is the way that I know of. So size t pointer block dereferenced is, sorry, 11. And then printf size t value this, and then size t block. Yeah, let's see what does this give us. Uh, it's unsigned. Okay, unsigned. Int abcd equal to 100. abcd. Call to undeclared library function malloc with type unsigned long. Malloc returns. Wait. I thought this is how it works. Oh, I have to cast it. Is that why it's happening? I can't. Hold the sign of p is equal to void pointer and malloc pointer plus equals size. Yeah, right. Why is it giving me that error then? And wait, I'm missing something. Is it supposed to be unsigned long? Let's try that then. Sorry, my bad. So, uh, what is it doing? So call to undeclared library function malloc. Malloc needs to be imported. It doesn't know what malloc is. Yeah, standard library. Is that why it is? So yeah, let's try to include standard library. So yeah, okay. Not used by format string. Size to data argument not used by format string. It's a warning, right? size t temp value is equal to casting size t block and then temp. Yeah, we're argument not used by format string, but that's size t, right? Yeah, right. We use ZU hex size t. Yeah, ZU. This should work. What is happening? Sorry. Also, let's do one thing. So yeah, let's leave block at the end. Sorry. So ZU temp data argument not use the format string. So just give me a minute. I shouldn't do it manually. I have set up shortcuts like okay. So I'm back. So yeah, let's get started. Why is ZU fading? Oh, okay. I saw. Okay, okay. Yeah, I was forgetting the posting sign. Wait, no, nothing. Seriously? Is it because it's null? Is it filled with like okay? How about if I go like this? No, my bad. I wanted to go it like this. Yeah, cast it into size tree and then oh, I'm such a oh boy. Yeah, fine. And who's going to execute that? I'm such a okay. It's reading something else. If we cast that into that, so do this. This should give us the 11. Yeah, perfect. That's what I wanted to know. So yeah. So now we have the block size value, and then so now we have block size value. Now we have to change the previous value and the next value. Yeah. So pointer to the y pointer to pointer. So what should we call it? Next pointer? Yeah. Next pointer is equal to let's cast it to void pointer pointer. So char pointer block plus slash normal plus size to size. Sorry. Uh, similar kind of things for the previous pointer. Just that we have to also move it by pointer size again. So pointer size, and then we'll do the fill. So next pointer should now become change next, and previous pointer should become change p here. So now let's call the function. So let's say uh, let's say block one is the start one, right? So blocks, yeah. So change previous next values. Yeah, so here we will write like block one. We need to change the title, a copy of it. Yeah, that's fine. So here we have to make it so that we given like the block one's previous value should be its next value should be block two definitely, and then its previous value should be sorry, its previous value should be null. For block two, the previous value should be block one. So what is it? Yeah, next value. Next value should be block three, and previous value should be block one, right? And for block three, next value should be null, and previous value should be block two. Nice. So now we do have like a working, like a constructed like free list, free block, free list, right? Let's make it like let's get the next value of that. So let's say yeah, let's cast it into void pointer to pointer free list. Let's say fake free list. So fake free list is no, we don't need that, right? Yeah, just give it a void pointer. So fake free list is like block plus size t size, right? Block's value. Since block's value is the starting of the block, that's why we are moving by size t size ahead. Sorry, yeah. And then we'll return this. We don't have to return this, right? Let's call my malloc over here. This should compile, right? Just a minute. I'm back. Sorry. So yeah, let's get started. So we should call three pointer over here itself. Sorry. So yeah, let's do it. So how about we? make it like, how about change the free pointer to this? Yeah, how about that? So let's say starting point free pointer was called over here. Here we will call the unit test, so which is test my malloc. So here we will call test my malloc, right? How to check if there was an error? Yeah, so now we have to call my malloc over here. Yeah, so we don't need this. We should make it so static free list, right? Void free pointer. Sorry. So it should point to block one. So yeah. So void pointer to pointer, free pointer, fake free pointer is equal to void pointer to pointer, free pointer itself, and then we change its value to fake free pointer to block one. Yeah, this should do it. Not block one, but fake free list, fake free, fake first block. Let's call it fake first block. Fake first block. Yeah, nice. So now our free pointer has that. Does this change the value of it, or does it like, yeah, we didn't have to do this, right? We could have done like, uh, let's say this, which is cross this void pointer to pointer, fake pointer is equal to void pointer, char pointer, block plus size to size. Boom. This should do it. Yeah, not fake pointer, fake pointer. Yeah, free pointer. Pass that into free, so free pointer over here. So free pointer is none, so it gets initiated as the block t size value, and wait, what does block mean? Should be block one. And just give me a minute. Yeah, I guess this should compile now. So, so uh, call to undeclared function test my malloc. So, oh yeah, yeah, I get it. I get it. So test my malloc hasn't been like declared over here. So we just do this. We have to do it for a lot of function, right? Yeah, okay. Void test my malloc. Change previous next values. Let's paste them over here. This is a void test my malloc construct free block. So void pointer construct free block. Just size. Okay. So size t size. Then void test my malloc. Okay, that's fine. So this should work. Yeah. Incompatibility to pointer conversion. Void pointer from size t to void pointer. Let me think. So it's 100 line. Yeah. Yeah. So align size. I call in here. We were getting error at which line? 115. Unused block size. Yeah. Oh yeah. It's unused. Yeah. Let's fix that first. So 124. Yeah. Yeah. We probably didn't need that. Yeah. We didn't need that. This is fine. And then let's go at 115. This is yeah. So void pointer block char pointer align size and size t value. Oh yeah. Got it. So this shouldn't be this. This should be size t. So it's here it is, and it should be size t pointer. My bad. Size t pointer. Yeah, uh, this should work. Yep. And let's add some like print statements. Okay, so we will add print statements inside my malloc function. So here we say now let's add some statements inside this. So yeah, this size block actual size. Yeah. So requested size and actual size. Yeah, let's add it over here. So we have to add a lot of statements, right? Yeah, let's do it. So here we will write Let's first comment about that. Temporary unit test, because this is fine for temporary unit test. Uh, we should use the specify, like there's a thing like if defined this, yeah, add comments, not add comments, but debug using if defined in C. Yeah. C processor directives. How to use them though? Yeah, let's just get started. So allocator dot allocator dot C underline here. So can I like break them? So like let's say I'm over here and I write hashtag if defined debug and then I write hash end if, right? And then again I define it over here. So hash if def oh debug, yeah. Let's call it something unique. So Aditya, that's my name. Debug Aditya. Let's keep it something simple. So how about debug debug code? Wow, very unique. So debug code hash hash and if defined, and then we'll add it entirely over here. So this is hash def debug code. I guess it's no problem for this to exist, right? Just don't want this to be called. Yeah, even over here we don't have a problem over here. Right, so let's say this go to 109. This is the only thing that we don't want to exist. So debug code and end it. Yeah, just end it. It's fine if these functions exist because they are not going to get called. And yeah, let's bring this function, bring this back. So now our diff should look a little better. Yes, so split block next pointer is improved. This okay. If defined, this exists. This. That's fine. So clear. Which branch are we in? Doubly. So this. Yeah. Get add. Get comment. Wrote a few functions. How about this is called unit test, right? So what are unit tests? Unit testing is the process of testing the smallest part of your code, like it's a method in which we verify the code's correctness by writing from one. It's a keyword. Yeah, let's call it unit test. So unit test for testing my malloc function. Yeah. Okay, so it's gone. Okay, so now we will, if we compile it, what put my malloc? Oh yeah, yeah. So this is just give me. Hey there, I'm back. So yeah, let's. Okay, so yeah, so my malloc. Yeah, this is yeah. Let's comment this out. So yeah, nice. So now, if we do like execute this, we shouldn't see anything, and we should just get segmentation error. Perfect. And now, if we do run this, wait, we also have to. ah, yeah, let's add some things over here. So so printf inside traverse function. So inside traverse function, looking for requested size. A block of bytes found, actual size. Okay, let's simply do this first. Uh, we haven't. We should free the memory too, right? Yeah, let's add the free things. Yeah, yeah, how about that? I hope this works. Let's call the smaller. You can say the smaller uh, function first. So cdmit, yeah, mdriver dash f, traces c0, run one trace file, right? Let's give it a shorter trace file. So ls, so which one is the shorter one? Short traces, sorry, yeah, short trace underscore v0. Yeah, so mdriver dash f, short traces, short trace, yeah, v0. In traverse function looking for 2040, in traverse function looking for 48. Hmm. Sorry. Oh, because we didn't add debug. Oh my God. Yeah. Oh boy. Uh, yeah. Please work. Please. Segmentation error. Okay. At least something that is different. That's fine. So segmentation error. So we got a segmentation error here. Why would we get that? Why would we get the segmentation error? Wait, so let's say I am inside the init. Yeah, inside init function. So we did reach inside init function, then we called test my malloc. So we go over here. So test my malloc. Okay. Then we should get printf inside change function. Okay. And then inside construct function. Yeah, okay. So inside init, inside test, inside construct, change. So our field is indeed created. So where are we missing the change, free pointer. Oh yeah, right. how about we make code changes over here? No, that's fine. So yeah, so change, working. So free pointer. So the value of free pointer, like the value inside it, has been changed to the void pointer of the block plus size t and the void pointer that we get to it. That's fine. That's correct actually. So first test is equal to my malloc. So we call my malloc over here. Let's go inside my malloc. And let's call it over here. Printf inside my malloc. Yeah, okay. So we are not going ahead of that. So we did end up over here. So this change did occur. Sorry. 57 minutes in. Okay. Okay. So we go over here. Is it because we are calling it with not a multiple of this? 1024. How about that? 1024 is a multiple of 8. So is that the reason? Because it is not aligned, but we are still aligning it. 128 should also be a multiple. Yes, it's indeed a multiple. So my malloc 128 is it supposed to get like is it supposed to be a size t value? Size t uh, request is equal to 128. Yes, that's not a reason. Sorry. Enter inside the not inside but after the assignment value change free pointer. Why do I come out of this function? I should just stay. Yeah, yeah, we are not going ahead of that. So something's happening over here. So free pointer is actually none. How about I do one thing? So so printf value of free pointer is currently, well, free pointer, so this should be 0. Yeah. So cast into the lock value. So the lock 1 plus size t moved ahead. Cast it back into void pointer. This should be the new value. That's how about we do this. So copy, yeah. So void pointer to pointer, copy of free pointer is equal to casting free pointer as a this, and then we change its value. So copy free, but this doesn't do anything. Yeah. So can we change the value of a pointer like a static? It's a static void free pointer, right? So it's null currently. And if we say, hmm, let's check what this looks like. So let's call it temp for now. So temp is equal to this, vt this, yank this, boom, boom, boom. Find equal dt boom, 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 boom. So at printf boom, temp looks like percentage p new line boom boom temp. Oh boy, why do I do that? Yeah, okay. So temp, yeah, okay. So we indeed get a value. So we are able to set it, but we are not able to do this. So free pointer, we are not able to cast it into void pointer to pointer. Is that the reason? Let's try that. So if we go over here, so let's say so this is a void pointer, right? Yeah. Let's remove these and let's remove these too. Return. So temp dot c and output 11. That's perfect. So now we don't need all of these. So how about we do this like so? So static. This will be a static block. Does this work? No, because it's not compiled and constant. Yeah, okay. So how about we make a new so static. Can we change the value of static variables? Yeah, we can. No, don't need to Google that. So static variables in C. Yeah, okay. Count is initialized to 0 and it's static, so it won't be redeclared to 0 again. So count is 0, 1, perfect, 2. Okay. Static. Yeah, the address stays the same. Okay. Repointer is equal to null. We remove this. We also remove this. So now we try to change the value of. So we don't want free pointer to point to null anymore. We want it to point to our block. So we'll do this. Where we cast the free pointer in as a where we cast free pointer as a void pointer to pointer, and then we dereference it to change its value to block. So let's say if this was print percentage p and let's say what's the value of let's say this is block, right? So now and then we when we do this void pointer temp is equal to dereference void pointer to pointer free pointer, and then we do this again just with temp. Yeah, segmentation. Why is that? So we can't cast that. Is that a reason? We are just saying that okay, so we cannot change the value of free pointer because free point. How about that the free pointer doesn't exist? Let's try that theory. So my another theory is that so free pointer doesn't exist. Um, it is pointing to null, right? but it's null, so we cannot perform. Okay, is that the reason? In C. So void pointer is equal to null. Void pointer is equal to null. Yeah, my work on what is the best way to check if the void pointer is null. My work on for now is it's equal to null. Seems like the best way, and then basically assuming pointer is of type void pointer to pointer. So, hey, so this works. Wait. Yeah, let's try that. So yeah, let's try that. So if void pointer to pointer, the pointer is equal to null, printf yo bro, I am null. No. So three pointer, is it because it's static? How to use static how to use static variables inside a function in C? Do they have like static variable inside of a function? Sorry. Foo. Yeah, it has a scope of like the entire lifetime, right? So it should be okay. So it cost 3.2. Is it because of like? Oh, I get it. I get it. This is the reason. Nah. Okay, I'm done. Void pointer to pointer this, and then equal to null. Sorry. I initially thought like it must be because of like the operator precedence. Yeah, that's not the reason. So this should compile. Yep. And then this is a pointer to a pointer, right? Its value should be the same as free pointer. So printf void pointer to pointer, copy free pointer, percentage p. So this free pointer, this should come out same. Yes, because it's a value. It's the value that it's pointing to, and then we want to change that value. So we want to change the value of free pointer. So we will say dereferencing, but that's like a totally different. Yeah. So dereferencing point pointer to pointer, free pointer to be equal to. Oh, right. No, not right. It's supposed to be block. Okay, how about this? How about I try this? This should not be possible because my world is going to crumble. Please, this should not be possible. Please. Okay, this is going to crumble my world. Like whatever I have learned is going to go to waste because my ideas. Please, yes, okay. Okay, okay. So let's get this. Sorry. So the segmentation fault. So free pointer. Change the value of a pointer. Yeah, change the value of a void pointer. Let's see. So they have a void pointer position is equal to data plus index of size. Position. Of course, that does not compile position value here. You should do this and copy. Yeah, it's not the same thing. So void pointer and C. Let's learn about it. So void pointer P is equal to the address of A. Wait, what does it mean? A void pointer is a pointer that has no associated that has no associated data type. So address of 10. Okay, dereference. Hmm. How about I give it like so they get a void pointer. So so void pointer object pointer and C pointing at num. V seeds end pointer and then dereference it with the value. Oh, this is taking a lot of time. 1 hour 19 minutes and this was a long video. This is a long video. This is a long video. Okay. Sorry. So copy feed pointer. So free pointer. Why is what is the reason? So block is a void pointer. Yeah, no need of this because we know it's a malloc and percentage p. So block. Can I see the address of it? Is this allowed? Yeah, that's allowed. Yeah, look, see, it's allowed. So so it's allowed. Sorry. Uh, Give me a minute, maybe. So copy pointer. Uh, so we tried a lot of things, but I don't think I get it. So block. It's a pointer. Block. So the value inside block is different. Yup, got it. I think I got it. So free pointer, the value inside free pointer must be, well, we consider the block that we are getting is actually a pointer to a pointer. Hmm. No, I don't get it. Even if we do that, we did try that, right? Yeah, it didn't work. So I don't know what's going to work, but I don't think we should be wasting this much time on this. So uh, let's am I audible? Yeah. So let's think about this. So void is a free pointer, it's a pointer to a pointer. We cast that. Does this create a copy? No, it does not create a copy. So copy free pointer, we don't need copy free pointer. Why do we do that? The value is different. If we do this, so let's say dereferencing void, like taking it as like int pointer. So dereferencing and int pointer block, and then we set its value to 11. So now nothing should change, right? Pretty much. Yep. But if we, it's pointing to the, Block is a pointer, it's a void pointer pointing to the memory address, the address of the block allocated to us, which is that. Let me draw a diagram. So a block is a void pointer and it's pointing to the block that they are given. So the value inside block is actually the address of the block. The value inside block is actually the address of the 100 bytes of block that is allocated. Yep. And if we want that value, then we have to say like this pointer is actually a pointer. And we have to say that this block is actually a pointer to a pointer to a pointer. And then we say the value at the core of it. We did try that, nothing happened. Oh boy, I'm so tired. Okay, pass. Let's give it a ChatGPT. Let me just hide my screen. There's no point in wasting this much time, right? Wait, let me do this. Yeah. Okay, so screen capture. Yeah. So what did it give? So void pointer, block, this block problematic line, step by step. So void free pointer is a global pointer variable initialized to none. Void pointer block allocates 100 bytes of the heap, returns a pointer to that memory stored in block. Print pointers, these are the output, this. Let's break that down. Free pointer is currently null. Yet void pointer to pointer, free pointer means treat free pointer as a pointer to a void pointer, means dereference the pointer and store block there. But since free pointer is null, I knew that. It's because of that null dereferencing it causes segmentation fault. I knew that. So in short, this line is equal to this. I knew it. How to fix safely? If your goal was to store the pointer block into free pointer, you should just write free pointer is equal to block. I'm so dumb. Oh boy. Oh boy. Oh boy. Yeah, it worked. After the value changes of after the value change of free pointer. Yeah, inside my malloc, inside traverse function, looking for one TDA, block of 10204 bytes found inside my malloc. It's your bytes found, a block of 1024 bytes found. Wait, so let's add that over here. So my malloc, yeah, okay. So inside my malloc, looking for a line size. Yeah, let's remove the useless things. Yeah, we don't need inside it. Let's try to construct. Yeah, this is fine. This is fine. This is fine. This we don't need. This we don't need. This we don't need. Yeah, the rest is fine. Mm. Okay, so yeah, inside my malloc looking for 128. Yeah, inside Java's function looking for 128. A block of 1024 bytes found. Inside my malloc looking for 204. Inside Java's function looking for 204. A block of 8080 bytes found. A block of 1024 bytes found. Why why 880? Because 880 is uh why 880? Because 1024 minus aligned would be 128. So if my math is correct, so if this is 1024, wait. So if I am calling 1024 construct free block, so I get, I align it, and then the total space that I'm going to ask for is 1024 plus 1024 plus 8888. That's 32. So 6. So this is 32. Let's try it. I'll show you what I'm talking about. So Control Shift K. Yep. See, we do have software right now. Previously we had to like drag the camera screen. Fine. So let's say I'll remove this. So let's say we have a block like this. Boom, 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 boom. So when we ask for 1024 bytes, then like we call the construct function with 1024 bytes. We don't use only 1024 bytes. We ask for more. So this is actually 1024 bytes. This is 8, 64-bit systems. So total, this is 1024 plus 32, 1056 bytes. So out of that, the first process uses 128 of it. So now this block becomes, so this is 1056, okay? 1056. So now the new free block that is, so now this block will break into two blocks. First will be this, boom, boom, 8, 128, 8. And now what is the rest of the block? So this is 8, 8, 8, 8 here, 24, 2 plus 2, 4, 144. So this is 144. So what must be the rest of the thing? So 1056 minus 144 to 912. So we know that the entire block is 912, right? But out of that 912, this is the new free block. So this must be 8, this must be 8, this must be 8, and of course we forgot this must be 8. So 912 minus 32. Oh boy, we have a working free list. How cool is that? We have a working free list. Well, partially working, we still have some errors to fix. Oh boy, okay. Let's fix it. It's fine. It's a 2 hour video. It's fine. Uh, but we do have a working one. So nice. High five. So let's get back to it. So we do have a working one. So it feels cool. So inside that, where do we have the error? Yeah, segmentation fault. We still are getting like segmentation fault. We shouldn't be, right? If I remove the debug, we won't get a segmentation fault, right? Can I put it? Yeah. Okay. So debug code. If I comment that out, and if I make it again, see, no errors. But if we still, okay. So let's find why are we getting a segmentation error. 1024 bytes found. Wait. So it looked for 880 1024, and then it went to the third block, the third 1024 bytes block. Hmm. Okay, I think there is some error inside, like the mem SPRK. Wait, just give me a minute. Yeah, okay, back again. So let's try to find what's happening. So when we reach the block, so let's when we reach the block two, we just end there. At least we should have got like the one third 1024, right? So let's go inside traverse function and let's write uh, inside traverse function looking for schedule requested size. Yeah, block of schedule b bytes. So previous to pointer to next block. Next pointer of the current block. Yeah, okay. Previous pointer of the current block. So previous pointer of the next block. So previous pointer of the next block. Sorry. Yeah, we'll fix this later. But today was a win. Today was a great day. Uh, I guess that is it. We wrote unit tests. There are some errors. That's fine. Let's commit that. So yeah, make clean. Yeah, construct this. Yeah, let's remove the print statements now. Insert construct function. Oops, sorry. Get def. So yeah, block to 1024, size t, temp. How about we git restore and just change this to like three pointer is equal to this. Yeah, yeah, yeah. Let's git restore. So q git restore. What was it? Three pointer. Yeah. So here we just change this to three pointer. And what was the other one? Yeah, 102 first, right? Yeah, no point in that. So git def. Yeah, fix this model. Yeah, git add, git commit. Hmm, let's go. Oh, today was a great day. I had a like a thing in my mind. I did keep I knew that it might be something related to null, but I was not sure. I did say it, but I guess that's fine. So yeah, what about WQ? And we did. Oh no, wait. So okay. So we'll do this. Yeah, over here. So I guess we did end up using ChatGPT because small brain, small, very small brain. But I guess that is it. Uh, we did break the no clanker challenge. But I guess it's fine. It's fine. We do need a help sometimes. There was no point in us being stuck, right? Like eventually I would have like figured it out, but it would have taken us 3 or 4 hours maybe, maybe. We already wasted like maybe 30, 40 minutes on it. So I guess, yeah. This is the longest video, and this was actually going to be the shortest one. Like initially the speed was crazy. Like initially when we were writing the first three functions, like the construct one, the unit test part one, uh, the speed was crazy. I was like, oh man, damn, we are moving so fast. Uh, I guess we messed up somewhere, but it's fine. It's fine. So I guess that is it. Uh, I'm at the Bachani, and I'm an engineer for fun. Bye.